Okay, we are moving on. We're still doing slope, but now today we're going to call it the rate of change. Okay, it's how a quantity is changing with respect to the change of another quantity. So now we're going to have like words to what we're doing. Okay, it's not just going to be X and Y. Like our first example here, X is the amount of flour and Y is going to be how many pancakes we get. So now we're going to have words that match up with our ratios. Okay, remember our rate of change is the change in our Y's divided by the change in our X's. Sometimes you'll see a symbol like this. It's called the delta symbol. It means the same thing. Change in Y, change in X. Okay. How would I get a negative number in here?
By negative, what's it called?
Like negative movement?
Yes.
Okay. So what is considered negative movement?
Going down.
Going down?
Or to the left.
Or to the left. Good. So down or to the left would give me a negative number. All right. So let's look at our first table. We have cooking. Find the rate of change of the function by using 2 points from the table. It doesn't matter which two. They gave me 3, right? It doesn't matter which 2 you pick. What do you want to do? The first 2? Yes? Is that okay? First 2 points? Okay. We can, since we're using points, we can still use the same formula that we used yesterday. Oop, that's not even right. Here we go. Y2 minus Y1 divided by X2 minus X1. Okay, so we're still going to use those 2 formulas to help us out. So a table of value is a table of points. If we're going to use the first 2, I'm going to go ahead and label this is going to be X1. I'm going to make this guy X2. I'm going to make this Y1 and make this Y2. And then I'm going to set it up. So we have, remember, we always have minus over minus, right? When would any of those become a plus? If we bring in another negative. Good. All right, so what is my Y2? 24. What's Y1?
12.
And then what's X2?
4.
4. And what is X1? 2. All right, so now let's simplify. What is 24 minus 12? 12. And what's 4 minus 2? 2, which gives me 6 over 1. Okay. So what does that mean? My Y's are pancakes, right?
Sure.
So this is 6 pancakes. We're going to give things words now. For 1 cup of flour. See how those relate to each other now? So how many pancakes can I make with 1 cup of flour? I can make 6. See how that works? If you like cooking or that's something you get involved with later in life, this happens a lot. Lots of ratios. All right. Look at your table. How did 12 become 24? How did 12 become 24? Well, we added 12.
Oh.
And then 24 to 36, didn't we add 12 again?
Yes.
So see how we were increasing by 12? And then here, this was plus 2, plus 2. Look at that, 12 over 2. Because my Y's changed by 12 as my X's changed by 2. Does that make sense? Kind of looking at it with tables? What's up? As long as it's doing it the same way each time. Like if it said 2, 3, and then 4, 6, 8, you would have to watch out for that. Yep. All right. All right, my next one. Find the rate of change. Amount of gasoline purchased in gallons and the cost in dollars. Again, you're about to start driving cars, right? You're going to have to start buying gas. So you're going to need to know what that price means and how much. So if you only got $15, you're going to need to know how many gallons of gas can I put in my car.
I'll pay for gas. My dad.
Okay? Eventually you're going to have to. Eventually you'll have to. Okay? So let's look at the table. Okay? Let's do our formula. Okay? Does it matter what 2 points we use?
No.
No. Which ones do you want to use?
I don't care.
3 and 7. I'm 3 and 6.
I'm looking at this one now.
Oh, 6 and
It's okay.
6. Wait, let me do that.
The first two.
The first two? Okay, let's do the first two.
First 2.
Okay, so this is going to be x1. We'll let this be x2. Let's have this be y1 and have this one be y2. All right, so what does my numerator look like? 1992 minus what?
Minus
1577. And then my denominator was going to be 6 minus
475.
4.75. All right, I don't have a calculator. What is that? 3.32? You think so?
So, Miss Alice,
Someone is too loud.
what do you have a question? No.
1992 minus 15.77 gives me 4.15. There we go. And then 6 minus 4.75 gives me 1.25. Okay. What's up?
So why do we start with the y, not the x?
Because that's the slope formula that we did yesterday.
It's white.
Change in y over change in x. Yep, rise over run. Okay, so let's put words. We have numbers. What are these words? So 4.15, is that the amount of gallons or is that the cost? Cost. So we spend, right? It is $4.15
X.
for 1.25 gallons of gas. Okay, that's what the ratio is showing me. It's showing cost over gallons. All right. We're good? Kind of. Do you get like where the words come from? Yes. We get what's y and what's x. And we write the change in y over the change in x. So that's how I know where my words go. All right. Determine whether each function is linear. If it is, state the rate of change. So for something to be a line, it has to have a constant rate of change, meaning our rise and run is the same thing every single time. Okay? My y's can't go up 1, then up 2, then up 3. It doesn't work that way. It has to be the exact same change of my y's over the exact same changes in my x. Okay? So looking at my A table right here, let's check out my y's. How does -5 become -3? I owe you $5. There we go. Now I only owe you $3 because I gave you back $2. Okay. How does -3 become -1? +2 again. All right. -1 to +1. +2. +1 to +3. +2. So my y's are good, but I have to also make sure that my x's are the same pattern as well. Okay. How does 11 become 8? -3. How does 8 become 5?
-3.
-3. 5 to 2. -3. 2 to -1. -3. So see how it's the exact same thing? Yes, Ms. Douglas. Thank you.
Yeah, Miss Alice.
Okay. So remember that little triangle means change. So those are how my y's are changing, and the other side's how my x's are changing. It is a function. So determine if it's linear. Yes, this is linear. So yes, it is linear. What is the rate of change? Am I going to say -3 over 2, or am I going to say 2 over -3? There you go. 2 over -3 because it's change of y over my change of x. Good job. All right. Ready for the B table? Yeah? You want to do the X's or the Y's first?
Why?
I heard Y's. All right, let's see how my Y's are changing. How does -4 become -1?
Plus 3.
Plus 3. There we go. How does -1 become +1? Uh-oh. How does 1 become 4? How does 4 become 6? So I don't even need to look at my X's, do I?
No.
Okay, but we are just because. Why not?
No, we don't.
Change in X. 22 becomes 29.
3. 4.
7. How does 29 become 36?
7.
36 to 43.
7.
43 to 50. Okay, so my X's were good, but what was the problem?
The Y's.
My Y's. They weren't all +2 or they weren't all +3. So this one is not linear. Yeah, not, I'm going to say not linear. All right. We doing okay? Okay. We got one more on the front, right? Okay. Let's do it. Okay, the graph shows the average ticket prices for the Miami Dolphins football team. Find the rate of change in ticket prices between 2009, 2010. Between which 2 years did ticket prices have the fastest rate of change? And between which years is the rate of change negative? Okay, Leland, what's up?
What?
Do you have a question?
I'm lost.
Okay. Okay, let's take it step by step. The first part, find the rate of change in ticket prices between 09 and 10. So those are labeled for me. I know it's small. Here we go, 09 and 10. So my Y values is what is being labeled. Okay, so I'm going to put part A over here. This is part A.
Okay, it's 64 to 70.
So my Y's, it's okay. So we're going to do 70.54 minus 64 point, what is that?
76, it looks like to me.
70, 74?
Oh, 74.
Let's call it 74. Divided by my years, 2010, 2009. Okay, remember these are my X's. That's X1, that's X2. This was my first Y, this was my second Y. Do we get where those are coming from? My first point and then my second point. All right, so 70, let's figure this out. 70.54 minus 64.74 is what? 5.8. And 2010 to 2000 minus 2009 is 1. So how did the price of the ticket change? How do I say? Okay, so in that 1 year, yeah, because 1 year. What is 5.8? That's money, right? So I don't usually say $5.8. What do we usually say? $5.80. Good. Did the tickets increase or decrease by $5? How do you know it increased?
Because
It's not negative. It is a positive number. So we're going to say price increased
So it started in year 1.
by $5.80 from 2009 to 2010. So our years were labeled for us. So it showed us in that 1 year the price went up. What's up? You gotta answer the question. It asked you a question. No, because you have to specify increase or decrease, and you have to specify how many years. It was just 1 year. So the price increased by $5.80 in that 1 year. All right, that's part A. All right, what was part B asking me? Let's see here. Between which 2 years did ticket prices have the fastest rate of change? Okay, this right here, this word, fastest. Do you think that's what my slope is going to like be kind of slanted or like super slanted? Super slanted, okay? So that shows the most dramatic change. So where do we see that happening?
2000.
So 9 to 10, that's a steep one. That's pretty steep.
2004, 13, 14.
13, 14 maybe? How could I'm guessing, but how could we prove it?
Get it back.
Let's find the rate of change between those 2 points, because we know between 09 and 010, right? So we're thinking it might be this or it might be this. We already know one of their rates. So let's do it for the second one, and then we can definitely say which 2 years had the most dramatic change. Right? So let's do 19 or what is that? 13 to 14?
It's that one, Miss Douglas. Come on, we already know.
What? No, we can't assume.
I'm not assuming. I can see it.
You can't assume.
I'm
You
not
have to be able to
I
know.
can measure out my finger. Oh, no.
All right, so this time my X1 is going to be 2013. Our X2 is 2014, so we're in between those 2 years. Okay. My Y1 is what? 71.14? Yes. And my Y2, what is that? 65.16? Okay. So our setup, Y2, which is 65.16, minus Y1, which is 71.14, divided by X2 minus X1. All right, so 65.16 minus 71.14 gives me negative 5.98 over 1. So what does that mean about my ticket prices? They decreased. And how do you know it's more dramatic? My number was higher. Good. So my first 2 years, between 09 and 10, it increased $5.80. Between 13 14, it decreased $5.98. Does that make sense? So we did prove, it did look like it, but we had to prove that this is the most dramatic change. This is where my fastest rate's going to be. Okay, so we're going to say between 2013 and 2014. All right. This had an increase of $5.80. There we go. Kind of put our answers with our questions. Between which years is the rate of change negative?
13, 14.
13, 14, yep. Is there anywhere else where it's negative? 10 and 11? Is that a slight drop? So it goes up, drops little, goes up, and then definitely drops down again. So between the years 2010 to 2011, oops, come on, pen, 2011, there we go, and 2013 to 2014. So to have a negative rate of change, what does that mean about my ticket prices? What did they do? They decreased. They got cheaper. If my rate of change is negative, then my prices went down. The rate of change went in the negative direction. Okay, I'm going to say tickets got cheaper. All right. Are we okay putting words with our numbers?
No.
All right. The back of this is going to be a review from yesterday. Okay, so remembering how to do that. I'm going to work through the odds, and then you're going to be responsible for the evens to get your stamp. Okay?
I'm not getting the stamp today.
I hope you do. So here we go. Moving on to the back. If you finished those problems yesterday and you show them to me, I will stamp them. The ones from yesterday, too. All right, so given the graph, find the slope of the line. So it is giving me 2 points between here and here. What are we looking for? Rise over run or run over rise?
Rise over run.
Rise over run. Okay, so how did the points rise? It went up 2, all right? And then it went to the right, how much? 3. Are any of those going to give me a negative number?
No.
No. Can I simplify 2 over 3? No. So my slope is going to be 2/3. We went up 2 and we went to the right 3. Does it make sense that my slope was a positive number? Yeah. See how the line, if I were to trace this with my pencil, moving left to right, my pencil would be going up. All right, let's look at number 3. Okay. They've labeled this point for me, and they've labeled this point for me.
I'm gonna have to steal the points on the paper.
Yeah, I know. That's why I'm trying to mark it. All right, so first off, my rise. Did it rise up or rise down? Technically, it fell down. And it fell down how much?
What in the world?
Oh, you're looking at the wrong one. I'm looking at the wrong one.
Yeah, you're looking at the other one.
6.
What is this? 1, 2, 3, 4. That is down 6, right?
Yes.
Down 6. And then I went over how many?
3.
3 to the right
Negative
3.
6.
There you go. -6 over.
That's gonna be 2 over 1, right? Or 1 over 2.
You were right the first time.
2 over 1.
Yep. You just make sure it is going to be negative.
-2.
Mm-hmm. So that one becomes -2.
So, do I just put -2 or if I put?
If you put -2 over 1, you're fine. That is technically correct. Because technically, look, if you go down 2 over 1, down 2 over 1, see how those are also points on the line? So it just did a little jump for the -6 over 3. All right, let's go to 5. If you're not sure where these points are, I'm going to mark them for you. I'm not doing it. I'm just marking them. So when you go to do it, you know where those points are. There's 2, 4, and 6 are yours. Okay.
It's 4 over 1.
Let's do this one. Okay. So number 5. Here is my first point. Here is my second point. How did I rise? I went up, and I went up how much?
4.
Went up 4, and I went over 1. So we went up 4 to the right 1. Are any of those going to be negative numbers? No. So what is 4 over 1? It's just 4.
I said that.
I'm not, you did do, yeah. I'm not going to like do it for you, but 4 and 6, you can use your Hoy bucks, right?
Yes.
Yes. Which one of these would be the Hoy?
The 6.
Vertical.
Horizontal.
And which one would be my bucks? This guy. So there's a little hint for you. If you are stuck on those, Hoy will help you with 6. Vux will help you with 4. Okay. All right, moving on to the bottom. Okay. So now they're giving me 2 points like yesterday, and they want me to find the slope. So yesterday when we did this, we labeled our x1, y1, x2, y2 every time. So number 7, the first point gives me x1, y1. So 4 is going to be my x1, right? 9 is my y1, it is. 1 is our x2, 6 is our y2. All right, minus over minus. How are we going to set up my numerator? The top. So what numbers are we going to put up here? There you go. And then my bottom? There you go. Good. Good. So 6 minus 9, it does give me -3. 1 minus 4 is also -3, which simplifies to just 1. We good? I want to show you something. So, if you look at this, 4, how did 4 become 1? It went down 3, right? And then how did 9 become 6? It went down 3. Yeah, my x's went backwards 3, and my y's went down 3. Doesn't that show up in my -3 over -3? So it matches. My movement is there. Yes, sir.
So what if I get negative on top from
Then the whole thing is still negative. Because it only takes one negative to make the whole thing negative. All right, moving on to number 9. All right, what am I going to label as x1? Good. What's going to be my x2?
Oh, shoot.
What's y1? What's y2? There you go. Good.
9, 3, 5, 5.
Almost. It should be -9 minus 3. It's okay. Joelle, why is it undefined? We're going to have a 0 at the bottom. Does it even matter what's up top? Doesn't even matter. Can you divide anything by 0? No. This was going to be what? What kind of line is this? It is a vertical line. Good. Member of X, vertical, undefined. It's x equals a number. My x's don't change. Look at my points. x5, x5. My x's didn't change. So this is going to be a vertical line. Okay. All right, now let's go to number 11. What am I going to label down here as your x1? What's going to be x1 in number 11?
-6.
14. What's going to be y1?
Oh, -6. -6.
What's going to be x2?
Oh. Think about this real quick.
And then y2. So first x, first y, second x, second y.
What number is this, 11?
Yes, 11. All right, so minus over minus. So what's my top going to look like? Good. -6 minus -8. Uh-oh. There you go. Change that to a plus. Good. And then this is 7 minus 14. I hear you. All right. 2 over -7. Good. Can I reduce that anymore? Nope. That one's done. You got it? -7. Because 7 minus 14 gives you -7. If you had $7 and I took 14, I would owe you 7. Doesn't make sense, but you get it. All right, 2 more. We got this. Number 13. What's going to be my x1? Thank you. What is y1? What is x2?
Oh. 2.
And what is y2? There you go. All right. Minus over minus. What's our numerator going to look like? -8. I heard that. +5. Good. Why did he say +5? Minus -5. Very good. And my denominator?
2 minus 7.
Almost.
2
Minus -7, right? Which makes it a +7. Good. Yep. So my denominator is 9. What's my numerator going to be? -3. Can this fraction reduce to what? -1/3. So the denominator is bigger than your numerator. So when you reduce, make sure it stays that way. All right. Seems like y'all feel good about this. We got one more. Number 15, last one. All right, what's my x1? What's my y1? There you go. x2, y2. Beautiful. It's all good. You got excited. All right, what does our numerator look like? 2. Yeah, 2 plus 1, because it was minus -1, right? Are we okay with that?
Yeah.
Okay.
-7 plus 5.
There you go. Plus 5, because that's my -5.
3 over 3.
3 over... -7 plus 5. I still haven't heard that. -2. Bonus question. Is this line going up or going down? Down. Good. How do you know? It is negative. It's a negative slope. There you go. Good. Okay. Awesome. I will love to come give you a stamp. So you're working on evens. Use your cups. If you have a question, please put them on yellow or red. If you are done, how about this? Let's do yellow for a question and let's do red for a stamp. Sound good? So I know what's going on. So yellow is a question. No. Yeah, is that what I said? Yellow is a question. Red is a stamp. All right.